Hello everyone! Welcome back to Xcoding with Alfian. This is the first part of the tutorial series where we will build the COVID-19 stats widget. In this first part of the tutorial, we will be focusing on building the UI widget to show the COVID-19 global stats data. We will be fetching the API from the COVID-19api.com, and we're also going to support all the family sizes from small, medium, and large. Along the way, we'll learn about the static configuration to set up our widget, as well as the timeline entry and provider to provide snapshot of timeline entries to the widget. So, without further ado, let's dive into Xcode and start coding. So, before we begin, let me show you the completed widget that we'll build. Let me toggle the jiggle mode on the simulator. With iOS 14, we can add the widget using the plus button at the top left corner of the screen. The screen shows all the available widgets. We can also search the widget that we want. Let's tap on it. Here, we have three different sizes of the widget we can choose: small, medium, and large. Each of the size maximizes the provided size given by the system. The small one shows only the total confirmed, sick, and recovered stats per row. The medium size uses grid layout to show additional sick number. The large size shows the pie chart as well as the percentage of fatality and recovery as well the grid of stats. We can add multiple number of widgets to the home screen. In fact, we can add all the sizes. That's it for the demo of the widget that we'll build. To begin the tutorial, please download the starter project from the GitHub repository. The project is located in the Part 1 starter folder. You can either clone or download the project. Let me open the starter project in Xcode. I am using the latest Xcode 12 Beta 4 when recording this video. Please download the latest one from Apple Developer Center for bug fixes and better stability. Also, if you encounter any issue when adding widget, such as blank widget, please delete the app first and install it again. Let me open the model file. This file contains all the models for the app. They conform to decodable protocol, as these will be used to decode the JSON from the API to the model. I'll show you the API that we use for this project a bit later. We also have the computed properties in one of the model. This will help us later to format the text for showing the stats number in the widget. Next, let me open the utils file. Here, we have a static constant number formatter to format the total stats number. In the initialization, we set the maximum fraction digits to 2 and set the grouping separator to true. Also, we have a string extension to convert 2-digit country ISO code written by the API to the associated country flag emoji. To fetch the COVID-19 global statistic case data, we are using the API from COVID-19api.com. Let me show you the response of this API using the POW app. Here, we use the summary endpoint. Let's trigger the request. Here is the JSON response. It returns the JSON containing the global lifetime total statistic and also the new cases in all countries per today. The model file already handled the decoding of the JSON to the associated data model. In this case, the daily summary case stats and the case stats struct. Now, let's open the COVID-19 API file. This file contains the API service that we use to make a network request to fetch the data. At the top, we have our API error enum with several cases. Then, we have a protocol to fetch 3 endpoints. Get global total count to fetch the latest global total lifetime stats. Get all countries to fetch the list of all affected countries. get total count to fetch a particular country latest total case lifetime stat. In this first part of the tutorial, we'll only focus on building the widget UI to show the global total case lifetime stats. We'll build a configurable widget that can accept an intent parameter for a country later in the part 2 of the tutorial series. I also provided the views to help us render the chart later in the chart views folder. It is a modified version from the original version created by Andres Samu. I have provided the GitHub repo in the description if you are interested. Let's create a new target for the widget extension. Click File on the menu bar. Hover to the New and click on Target. Click on the Filter search bar. Then type Widget. Select the widget extension from the list and click Next. Name it as COVID-19 StatsWidget. Uncheck the Include Configuration Intent. Click on Finish. Click on Activate Scheme from the dialog prompt. The new scheme for the widget extension has been created, as well as the target extension folder containing the assets, plist, and the COVID-19 StatsWidget.swift. In the project navigator, let's create a new folder named Shared at the root level of the project. We'll put all the shared files used in both app and widget extension targets. Select the model, utils, COVID-19 API, and all the files inside the chart views folder. Drag it into the shared folder. Delete this one. Select all the views inside the shared folder. Navigate to the File Inspector and check the COVID-19 StatsWidget extension inside the target membership. With this, our widget extension will also have access to all of the components here. Open the COVID-19 StatsWidget.swift file. This file contains all the required components to run the widget. The entry point of the widget is the COVID-19 StatsWidget struct. It has the main keyword at the top. As you can see in the body implementation, it returns static configuration, passing the provider, and a closure that returns the SwiftUI view given the entry data. Scrolling to the top of the file, we can see the provider struct that conforms to the TimelineProvider protocol, as well as the simple entry struct that conforms to TimelineEntry protocol. We won't be using these structs. Instead, we'll create our time entry and provider from scratch. Before we begin creating the provider and the timeline entry, let me show you the diagram of the WidgetKit. So basically, we have a configuration, in this case the static configuration, and then we configure the widget with a timeline provider and use SwiftUI views to display the widget's content. Then the timeline provider tells the WidgetKit when to update the widget content using the snapshot and timeline entry. First, let's begin understanding the timeline entry. Let's take a look at the documentation. Here it said, basically timeline entry is a piece of data that specifies the date to display a widget. The timeline provider creates one or more timeline entries with dates that tell WidgetKit when to display a widget. To render a widget, WidgetKit executes the content block of the widget's configuration, passing the corresponding timeline entry. We'll learn more about this later in detail when we implement our timeline provider. It also said that when you declare a structure conforming to timeline entry, include any additional information that the configuration's content block requires to render the widget. Okay, so basically we need to also provide a property containing the data that we want to render in the widget. In our case, we want to render the total case statistic number, which the total case count struct in the model file represents. Okay, let's implement the entry first by creating a new file named totalcaseentry.swift inside the widget extension target. Make sure the target is set to COVID-19 stats widget extension. Import WidgetKit at the top of the source file. Create a total case entry struct. Make sure it implements the TimelineEntry protocol. We need to declare the mandatory date property. There is an optional property named relevance which can be used to determine the relevance of the entry. This is used in the case of providing relevance score in the Smart Stack widget, so it can show information that is relevant to the user at the right time. We won't be needing this property for this part of the tutorial. Next, declare the total count property with the type of total case count. This is the model that contains the title and all the numbers for the confirmed, sick, and recovered stats. The last property is the placeholder property. This is used as a flag to determine whether to render placeholder in our widget in transient situation, such as when user adding the widget from the widget selection screen. Also, let's create an extension for the total case entry. Declare the static computed property for the stop and the placeholder data. This will come in handy later when we want to stop the data in the live preview. That's it for the total case entry. Let's move to the TimelineProvider implementation. Let's search for the TimelineProvider in the documentation. The description said it is a type that advises WidgetKit when to update a widget's display. Let's scroll to the overview. Here it says, at various times, WidgetKit requests a timeline from the provider. A timeline is an array of objects conforming to the timeline entry. Each timeline entry has a date, and you can specify additional properties for displaying the widget. Okay, so we can use the total case entry that we have created before in the timeline. WidgetKit asks for timeline entries in one of two ways. A single immediate snapshot representing the widget's current state. An array of the entries including the current moment and, if known, any future dates when the widget state will change. Okay, let's start implementing the TimelineProvider so we can understand it in more practical way. I'll keep the documentation open so we can find more description later as we implement the protocol methods. Create a new Swift file named global total stats TimelineProvider. Import WidgetKit. Then declare the global total stats TimelineProvider struct and conforms it to TimelineProvider protocol. As the protocol uses associated type for the timeline entry, we need to declare the total case entry as the type alias. Also, declare the property name service and assign it with the COVID-19 API shared singleton. We will use this later to fetch the global total case data when we generate the timeline. First, implement the placeholder in context method. It returns the single total case entry. In this case, we just need to return the total case entry placeholder stub we have created before. Next, we need to implement the getSnapshotInContext method. It has context as the parameter and a completion closure callback containing the entry. With the closure, we can make an asynchronous API call to retrieve the data, create the entry, and invoke the closure passing the entry. Let's take a peek about this method description from the documentation for better understanding. WidgetKit makes the snapshot request when displaying the widget in transient situations, such as when the user is adding a widget. WidgetKit provides a context parameter that includes details about how to use the entry, including whether it's a preview or the widget gallery, and the family or size of the widget to display. If context.isPreview is true, the widget appears in the widget gallery and requires quick response from your provider. If the information you need to generate the snapshot is not readily available or requires additional time to load, use the sample data instead. Let's implement this inside the body. We can check context.isPreview using the if condition. If it is true, we just need to invoke the completion closure callback, passing the placeholder total cache entry. In the else block, we need to fetch the data from the COVID-19 API and transform this into the data of total cache entry. Let's create a private method for this, as this will be also used in the provide timeline methods later. Declare a method named fetch total global cache stats. It has a single parameter that accepts a completion closure with parameter of total cache entry results. In the body, we just need to invoke the COVID-19 API service get global total count method. Then in the closure, we use a switch statement on the results. In case of success, we retrieve the associated stats value and initialize the total cache entry with the current date. Also, we initialize the total cache count model, passing the hard-coded globe emoji as the title. For the confirmed death and recovered, we just pass it from the cache stats as shared properties. At last, we invoke the completion closure, passing success with the entry. In case of failure, we just need to invoke the closure, passing failure with error. Let's fix this date initializer. Let's go back to the snapshot implementation. In the else, we just need to invoke the fetch total global cache stats method. In the completion closure, using the switch statement, we pass the entry to the closure in case of success. In case of failure, we pass the placeholder stop entry to the closure. Next, let's implement the second required method, getTimelineInContext. Let's see the documentation to find more about what this method does. So, WidgetKit makes the timeline request after the user adds your widget from the widget gallery. Because your widget extension is not always running, WidgetKit needs to know when to activate it to update the widget. The TimelineProvider generates informs WidgetKit when you would like to update the widget. If your provider needs to do asynchronous work to generate the timeline, such as fetching the data from a server, store reference to the completion handler, and call it when you are done with your async work. Okay, so looking into this, basically we need to invoke the completion handler passing the timeline object, containing the timeline entries array. The WidgetKit will use the date in each entry to determine whether to render the widget with the data in the entry. In our case, we need to fetch the latest global total case stats from the COVID-19 API. The response only provides data at one specific time, so we just need to fill the timeline with one single entry. Let me show you a diagram that can represent this. Another use case that can have multiple entries of timeline is a calendar app. It is possible to retrieve our calendar events in advance because most of the people schedule their events in advance before. For example, meeting at 10 a.m., lunch at 12 p.m., planning at 2 p.m., and so on. In this instance, we can fill the timeline with multiple entries and advance. The timeline also provided an API for refresh policy in case we have already advanced through all the timeline entries. Let's take a look here. When creating the timeline, the provider specifies a refresh policy that controls when WidgetKit requests a new timeline. The default behavior is to use at end to request a new timeline after the last date specified by the entries in a timeline. However, if there is a different date when WidgetKit should request a new timeline, you can specify a refresh policy of after date. In the case of our stats widget, the COVID-19 API updates the data every 10 minutes. So we can use the refresh policy of after date passing 10 minutes of the current date to refresh the widget. It is also possible to pass never as the refresh policy. In this case, to be able to request a new timeline, we need to manually refresh the timeline from the app by calling the WidgetCenter reload timelines method. This will be useful in the case such as when we this will be useful in the case such a this will be useful in the case such as when a widget's content is dependent on the user being logged into an account and they aren't currently logged in. Let's implement the getTimeline method. We just need to invoke the service fetch total global case stats method. We just need to invoke the fetch total global case stats method. In the closure, we use a switch statement passing the results. In the success closure, we initialize the timeline struct, passing single entry to the entries array. For the refresh policy, we want to use the after date policy. We want to refresh the timeline after 10 minutes, so we can just pass the current date and use the adding time interval method, passing 60 seconds multiplied by 10, which equals to 600 seconds or 10 minutes. Make sure to invoke the completion passing the timeline. In the failure closure, we just need to initialize the timeline struct, passing a placeholder entry to the entries array. We'll set the refresh policy after 2 minutes, which is 60 seconds multiplied by 2. This will refresh the timeline and call the API again after 2 minutes. We don't need this error failure. That's all for the timeline entry and the TimelineEntry implementation. Now, let's focus on building the widget UI. Let's begin by creating the small size widget. Here, we can see the widget. At the top, we have the header containing the title and the last sync date. After that, we have 3 rows of cases from confirmed, that's, and recovered. Each case has different background. In Xcode Project Navigator, create a new folder named Views. Then, create a new SwiftUI file named StatsWidget small inside the folder. Let's start implementing the top header first. As we can see, both the small and medium widget share the same view for the header. Let's create another view for the header so we can reuse it later when implementing the medium-sized widget. Inside the Views folder, create a new folder named Comments. Then, create a new SwiftUI file named title.header. We have two kinds of data by looking at the UI, title and the date. Let's declare the two properties. Next, import WidgetKit at the top. We'll use the preview context modifier, passing the widget context to preview the UI as a widget. Pass the system small to the family parameter. Also, pass the stub title and date to the title.header preview. In the body, to position the text horizontally, let's declare the h tag at the root level. In the view builder closure, declare the text passing the title. Set the font as system size 16 and the width as semi-bold. Then, for the second text, we can use the new SwiftUI 2 text initializer that accepts a date type and the format style. We just need to pass the date and time as the style. There are many different styles such as offset, relative that you can experiment with. Add the line limit modifier passing 1 to the h tag. Also, add a minimum scale factor as 0.7 to automatically shrink the font size in case the text is too long. Let's look at the results in the live preview. Looks good. Below the title header, we have 3 rows containing the case title and the number with a colorful background. Let's also create this view separately as it will be used for all the sizes. In the Comments folder, create a new SwiftUI file named case.view. Let's declare all the constants for the colors at the top. We have 4 colors: confirm, depth, recovered, and stick colors. There are 4 properties that we will be needing for this view: text with type of string, total count text with type of string, color, and optional height property with type of CGFloat. Also, let's import the WidgetKit and set the preview context modifier as the widget context. In the body implementation, as the text are stacked vertically, we can use the vstack at the root view. In the view builder closure, declare the first text passing the total count text. Set the font system size to 16 and the width to semi-bold. For the second text, pass the text property. Set the font system size to 12 and the width to regular. Let's add several modifiers to the VStack. First, the line limit. Let's pass 1. This will set the maximum length of the text to single line. Second, the minimum scale factor. Let's pass 0.7. And next, we're going to set the text color to white. Set the padding for the horizontal sides. Set the frame max width and max height as infinity. This will try to fill the proposed size given by the parent. An additional frame modifier to override the height set by the previous max height. We're going to assign the height optional property. And at last, set the background by passing the color. Let's see the results in the live preview. Okay, looks nice. With all the views in place, let's go back to finish the implementations of StatsWidget small view. Let's add a property named entry with the type of total case entry. Let's also set the preview context to the widget preview context. Let's stop the entry with a stop data. In the body implementation, declare the VStack at the root level. Set the spacing to 0. In the view builder closure, declare the title header. Pass the entry the total count the title as the title and the entry's date. Add the padding modifier passing vertical with the value of 4. Then add additional padding modifier passing horizontal. Below that, declare the cast stat view. Let's pass the text as confirmed. For the total count text, we're going to retrieve it from the entry, total count, confirm text. And the color, we are going to use the confirm color. Let's rename this. Let's declare the same case stat view for the death and recovered case. Looks like I set the wrong value for the recovered color. Let's fix it. It should be 213. Okay, amazing. The small widget looks good. Before we move to building the medium-sized widget, let's add the placeholder state in case of the widget enter transient state, such as when user adding a widget. SwiftUI 2 makes this very easy with the redacted modifier. Add it in the VStack. For the reason parameter, we can check if the entry is placeholder. If true, we just return the placeholder reason. If no, we return an empty initializer for the reason. To test this, change the total case entry in the initializer to the placeholder. Looks good, but the vertical position seems off. Looks like the offset Y is incorrect. I think this is the bug as of Xcode 12 beta 4, because when I build this with the beta 3, the offset seems perfect, just like this screenshot. I'm sure Apple will fix this before the final release of the Xcode 12. Next, let's build the stats widget for the medium family size. Here, you can see at the top we have the title header just like the one in the small family size. Below that, we have a vertical grid layout with two equally width columns per row. The item in each grid use the same cast stat view we have also created before. So the only view that we need to build is the container grid view. This view will also be used in the large family size later. Create a new SwiftUI file named cast.grid inside the commands folder. Declare two instance properties. Declare the two instance properties. First, the total count with the type of total case count. Second one, the columns with the type of array of grid item. We provide a default value here, containing two equally with flexible size grid item with zero spacing. Let's also import WidgetKit and set the preview context as the widget preview context. Let's pass system medium as the family. Also, let's stop the total count. In the body, we declare a fish tag at the root left. Inside the view builder closure, we'll wrap the lazy v grid inside a geometry reader. The purpose of this is to be able to get the container view height and set each of the item height manually. As we have two rows in the grid, the height of each item will be the height of the container proxy divided by 2. Declare the lazy v grid, passing the columns property. Set the spacing to 0. In the view builder closure, declare the cast stat view. The first one, we pass the confirm text. Let's get the total count from the property. Confirm text. Let's use the confirm color. And for the height, we can use this proxy.size.height divided by 2. Let's copy this and use the same approach for the other cases. Let's see the results in the live preview. Yeah, looks good. Now, let's create a new SwiftUI file named StatsWidget medium inside the views folder. Declare a single entry property with the type of total case entry. Let's import WidgetKit and set the preview context as the widget context. Pass the system medium as the family. And also, let's pass the stop data. In the body implementation, declare the fish tag at the root level with spacing z to 0. In the view builder closure, declare the title.header. Pass the entry.totalCount.title and the entry.date. Below that, declare the cast stat grid, passing the entry total count. Let's add a padding for this, vertical to 4 and a horizontal. Looks good. And let's also add the redacted placeholder here. That's it. Awesome. Now let's build the last size that we support, the large family size. Let's take a look at the large widget here. We can see that it is divided into two parts. The top part contains the pie chart and the percentage stats, as well as the title and the last date sync. The bottom part contains the cast stat grid we have created before. Okay, so first let's implement the top part of the view. Create a new SwiftUI file named cast_row in the command folder. Declare two properties inside the struct. Total count with the type of total case count and the date. Let's also import the SwiftUI. Let's import the WidgetKit and set the preview context as the widget context. In the body implementation, declare the edge tag as the root view. Add a padding modifier. In the view builder closure, declare the pie chart view. It accepts several parameters: the data containing array of tuple with type of double and color. This array items is the segment inside the pie chart. We just need to pass the total count of sick, death, and recovered, as well as the associated color. Actually, we need to pass the recovered, sick, and death. The next one is the form parameter. This is the frame size that will be used to render the chart. We'll be hardcoding this to 200 by 160. Let's move on to the next one. Below the pie chart view, declare a vstack with spacing of 16. Add a padding modifier passing trailing. In the view builder, declare a vstack with spacing of 2. Inside, declare the text passing the total count title. Set the font as the system size 30 and width to semi-bold. Next, declare the text passing the date and set the style to time. Set the font size to 16:12 and width to semi-bold. Below the vstack, declare another vstack. In the view builder closure, declare the text passing the total count recovery rate text. Set the font to system size 28 and the width to semi-bold. Then set the foreground color to recovered color. Add the next text passing the hard-coded recovery rate string. Set the font to system size 12 and width to regular. Let's do the same one for the fatality rate. That's it. Let's see the results here. Awesome. Let's implement the StatsWidget next. Create a new SwiftUI file named StatsWidget in the views folder. Declare one property named entry with the type of total case entry. Let's also set the preview context to the widget context. Pass the system large as the family and make sure to pass the stop total case entry. In the body, declare the vstack passing spacing as 0 as the root view. In the view builder closure, declare the case pyro. In the view builder closure, declare the case pyro passing the total count and date from the entry. Below, declare the case stat grid passing the total count from the entry. Also add the redacted modifier for the placeholder. That's it. It looks nice in the preview. We have built the widget for all the family sizes. Now let's create an entry view for the widget that returns the associated view depending on the environment widget family value. Create a new SwiftUI file named StatsWidget inside the views folder. Declare the entry property with the type of total case entry. the preview context as the widget preview context. Also pass a stop entry here. In the body, we can use the switch statement passing the family environment prop. Also, we need to declare the environment property wrapper for the widget family. Let's name it family. In the body, we can use the switch statement passing the family environment property. For the system small case, return the StatsWidget small passing the entry. Let's do the same one for the other family size. Okay, this should handle all the family sizes. For the final setup, go back to the COVID-19 StatsWidget file. We need to delete all the generated provider entry and the placeholder view because we are not using it. Inside the COVID-19 StatsWidget body, pass the global total stats timeline provider. In the content closure, initialize the StatsWidget entry view passing the entry. Set the configuration display name as COVID-19 stats. Set the description to show latest global lifetime stats. Let's also update this. That's it. Now we can just build and run the app from simulator or your iOS 14 device. Okay, let's try to build and run. Make sure to select this COVID-19 stats app as the scheme and build. Make sure to select the COVID-19 stats app as the scheme and build. Okay, so let's go back to the home screen and toggle digital mode. Let's select this COVID-19 stats. Here we have the widget. Let's add the medium size first. Okay, looks good. And let's add the small size. And at last, let's add the large one. Don't worry if you see the blank widget in here. This is a bug from Xcode, I think. Let's just add this and look, it shows perfectly. Before I close the tutorial, I want to show you how we can tell WidgetKit to reload the timelines programmatically from the app. Let's go to the content view in the app target. Import WidgetKit at the top and declare a button in the body. For the title, pass the reload timelines. And inside the action closure, we can just use the WidgetCenter singleton and invoke reload all timelines. Okay. So if we tap on the reload timelines here, the WidgetKit will reload all the timelines for our widget. That's it for this first part of the tutorial series where we build the COVID-19 stats widget. To recap, we have learned about the TimelineEntry and TimelineProvider, as well as building a widget that supports all the system family sizes. At last, we have learned about using StaticConfiguration to set up our widget. In the next part of the tutorial, we will learn about the intent configuration widget, where we can pass a custom parameter to our widget using a SiriKit custom intent definition file. So, until then, let's keep the lifelong learning goes on. Bye!